I don't hear you anymore.
Yes, record in the cloud.
Yeah, that's what we got going. Very good. All right, let me pull things up here and let's get started. For those of you who are just joining us, we are about to start our presentation, our feature presentation for the evening. We've just finished the NAWCC Chapter 21 monthly meeting, and we're moving on to the program. So yeah, once again, I want to repeat my welcome to all of you joining us from non-Chapter 21 chapters. We're happy to have you here. We hope we'll see you in the future again for future presentations and other things of the nature. So, and feel free to jump in and ask questions. We're all part of the same family here, so we're happy to have you here and want you to benefit from the things that we're doing. And David, do I have the full screen now?
Yes, I think you do. Folks can turn off all of the pictures that they want of individual folks tuned into the meeting, and then they'll have a full screen of the PowerPoint.
Very good. And David, again, can you see my cursor now?
I'm not seeing it now, no.
You're not seeing it? Okay. Well, I'm going to have to say, Tim, you can see it?
Okay, I'm seeing it. It's real small, but
yeah. Okay. Well, I'll try to not rely on the cursor then, but I'll use it to point, but I won't rely on it. Okay. All right. So just a little bit of a background here before we get started, even with the forward. This presentation comes about from, I'm not sure I can even recall how many years of screwing up motors trying to repair them, whether they be rotors or motors or whatever. The difference is that in those days, you could buy replacements. So I cuss and swear at the doggone thing and then just go out and get another one. Guess what? They're not available anymore. That makes things a whole lot more challenging because now we have to repair them if we want to get our clock to work again. So that's kind of a big change in the way things have gone. And it wasn't long ago that you could actually buy a replacement for the general time motor that's found in many such Seth Thomas clocks. You could buy a replacement. It wasn't really very a friendly replacement, but it was a replacement. Time Savers and other suppliers, well, not so much anymore, at least not that I know of. And maybe some of you have huge collections of motors sitting in your back room that you bought long ago, and that's fantastic and good to hear. But maybe not so much most of us. I know I don't. I've got a bunch of old junk motors. That's about it. So if I lose a rotor or something, I can replace it, but not the whole motor, no more. And what happens, I have found, is that over time, deterioration sets in, and pretty much all of these motors are in the same sorry shape. So even if you find a new old stock motor, you got to look it over really carefully because chances are the oil is hard, the lead wires are starting to crack, and perhaps the bobbins are also deteriorating. We're going to address all those issues, but it's just, my point is, it's just getting really, really hard to find a way to get these clocks running without learning how to fix the doggone motors. So that's why we're presenting what we're presenting here. And as I said, I finally have the confidence to get up and talk about this because I think after having screwed up enough of these things, I can show you how to avoid screwing them up, or at least I hope I can. So that's the first part of this. The next part of it is, I mean, obviously, electric clocks seem to be, at least from my perspective, regaining popularity. And as I said, they're all kind of dying from the same doggone thing. And it's usually the motor has a lot to do with that. And the rest of the clocks, generally, we're used to knowing how to repair those. And it's usually the same kinds of things. Some of the materials are a little different, but for the most part, repairing an electric clock, other than the motor, is the same as repairing any other clock. So And, you know, our customers, they love these things. They absolutely love these clocks and they want them repaired. So we don't want to leave them in the dust. And, you know, you get various, I'll just say, reactions when you tell them that you would recommend replacing them with quartz movements. My customers basically would come after me with an axe if I said that. So that's not an option, at least in my experience. Now, some may find that to be okay, but if once you've done that, it's irreversible. Unless they keep the movement, you can't get the clock back to its original form. And you might want to realize or think about the fact that most quartz movements are about 5 grades poorer in design than the original motor is that you're taking out and replacing, movement motor combination. And if you could get that motor running again, it's possible that clock could run another 20 years, maybe longer. Now, one caveat in all this. To do what we're going to talk about here, right here, you need to have basic lathe skills. You cannot make this work without that. So we've gone through the trouble of teaching multiple lathe classes here at Chapter 20, in Chapter 21. We've done many workshops on that, Saturday workshops, thanks to the support of Dick Shelton and Emily Griffith School. We've been out there showing folks how to use the lathe. So, and the basic skills that we've taught should suffice in getting you to where you want to go with this. Now, we're not going to talk about fabricating new fiber wheels here. We could later at some point. That's a whole different topic, and it deserves a different treatment. So as I said, this is the first time that I've shared this. So what I really would like to hope for is that you learn from what's here, you ask questions and develop some understanding. I'll probably put it up on multiple websites if needed. We could add more to it, but this is what we have now. But what I really ask is that no one takes the information that's in this and creates a DVD and starts selling it on eBay. I mean, I'm all for sharing, but that's stepping to the line, on the other side of the line, just a little bit too much. And, you know, it would, out of just basic courtesy, I'd ask that kind of nobody do that. and worse yet, label it as their information. So at least acknowledge Chapter 21 if you're going to share this with someone else. I don't mind that. So, okay. So here's the agenda. We're going to cover 2 motors today. One is the infamous, you can see it there to the right, the Hammond synchronous rotor, non-self-starting. This guy needs a little push to get going. That's just the way they are. And on the bottom, we show the General Time Seth Thomas motor. The reason it may or may not look familiar to you is because there were so many variations on the appearance of this motor. Same basic design. Mounting, there's at least 4 or 5, maybe 6 mounting methods on this motor. Problem is you can't take one mounting method and convert it to another and use the darn thing without a lot of effort. And quite often, it's easier to repair them than it is to try to change the mounting. So now, one important point is that the Sessions motor that you've all seen, it has the same basic look and feel. Same process to restore it. There's not a lot of difference at all. So this all carries over. We're going to focus on this guy, but it all carries over to restoring Session motors too. Okay, so there's some tubing supplies you're going to need. And the fact of the matter is that if you go to Home Depot and sweet talk the right people, you might be able to get these free because these are scraps. They're a 2-inch Schedule 40 conduit PVC. You'll need 1 inch of that. 2 inches of Schedule 40 brass. You'll need 3 inches of that. And 1.5 inches of Schedule 40 brass. Again, 1 inch. That's it. 1 inch of this. So somebody somewhere, and if nothing else, you can buy a nipple from those stores. Always carry small nipples, and chop off the threading, and you've got the same basic thing here, I think. So you're going to need these no matter what. So let's start out with the Hammond rotor, which as most of you know, you find in a lot of collectible Hammond wall and desk clocks and beyond. I mean, some of the ones you might be familiar with are Skyscraper and Postal Telegraph. Those are very, very popular. And it even turns up in Sessions, Chime and Strike. Beautiful mantle clocks, all sorts of case styles. And they use this doggone rotor. So it helps a lot if we can revitalize these things. So what actually goes wrong with these darn things in the first place? Well, the number one cause of death at these things is sludging and the resulting wear. The sludge is basically a varnish-like consistency, and you cannot get at it. Well, you can get at it, but you can't get the solvent out that you think is actually dissolving the sludge. Man, I'm going to tell you something. I take these things apart and I soak them in xylene to get this doggone sludge out. There's no way you can get that out from the outside. You just got to get in there and get these things clean. And also, no amount of cleaning is going to fix the wear, and wear is a problem with these things. So output shafts wear, that'll create oil leaks. The output bearings wear. There's some internal plate holes in these things. There's a rotating disc with a center bearing and a steel support. All those things can wear. Now, I grant you that quite often you don't get a lot of wear on these except for the output bearing, but still, you're going to see it. If you don't fix those issues, you're in no better shape than you are if you put a clock back together with worn bushings and pivots. It's the same principles. So this is the way you go about disassembling these Hammond rotors. The first thing, there's a little oil button in these things that was originally used in the upper left picture there to squirt oil in. And if you're tempted to take that button out and squirt more oil in and put it back in, go ahead and do that, but you know, your customer is going to be back. So the first thing you got to do is get that button out of there, usually just heating that area with a small torch and, you know, lightly tapping it on the desk will knock that button out, and then we can get to cleaning it up later. Second thing is get your 1.5 inch or your 2-inch PVC inch long. Not critical the length. I wouldn't go much over an inch or even 1.5 inches though. Then what you're going to do is you're going to mount the rotor in that piece of PVC. Now, it may fit as it is right from the Home Depot store, or you may have to bore out just a little sliver of it, and you can see how little there I had to bore out in order to be able to use this thing. That's how close this doggone piece of 2-inch PVC is to perfectly accommodating the bodies of these rotors. So I think if you're looking ahead here, you can see the next thing you do is just clean up that front lip on that rotor, mount it in and clean up that lip on the lathe. Just get the excess, you know, solder away from there so that you can then flip this thing around, as you can see in the bottom view. And that's the way we're going to work on this rotor from here on out. We're going to push that little lip into that piece of PVC, and we're going to turn off that solder. So let's take a look at that. So you can see here, we want to slowly turn away this solder until we're down to, and it cuts like butter. That's nature of solder. You can see the slivers there. You're going to clean that off all the way down to the lip of the rotor. And as you continue to do so, that lip, I mean, these cases on these things, they're like 12 thousandths thick material. It won't take you very long before you get down there and cut through it. Now, on our previous picture, we showed the angle you have to set that cutter at, and the more angle you can get, the better, because you want to get into that corner, and once the solder is gone, just start cutting into the brass. And if I mean, granted, you could come up with a better tool than I show here. You could come up with something that's pointed, maybe a modified boring bit or something. Just get into that corner and work it away. Sometimes what I end up doing is once I've gotten all the solder away, I'm down to a very thin material, is just go at it a little bit with an X-Acto knife until you cut through the remaining slivers of brass. And on the right, you'll see what happens. The lid pops off. Voila, you're in. And you haven't damaged the lid. That is key. Don't damage the lid. Now we want to get the pinion off, and that's pretty simple. What we do is we put one of these Infinus Crowfoots to work and push that pinion in there good and tight, so you're working on some reasonable meat. Don't have it just hanging on the edge of a tooth, or you'll start shearing teeth off. So be careful of that. One tap usually with a punch, and use a towel to catch the movement. Don't let it fall on the floor and bounce around. You don't want to distort it. And guess what? The pinion pops right off. And now we get to the movement itself. And easy as 1, 2, 3. You can use a ring tool, pry on it, and pop. Off come the rivets, one at a time. being careful not to pry against a wheel or something in there. You just got to look what you're doing. And off come the plates. And when they do, this is what you got. This was actually another rotor that I had in the shop. And you can see this one's all full of nice green gunk. No, it was not originally like that, but over 100 years or pretty close to it, that's what the oil ends up looking like. So you can see there that, and again, just to kind of, we're going to talk about cleaning some more, but I've found that xylene is the best thing to dissolve this doggone gunk. And it's pretty important to get it all out of there, because if you leave any of that gunk in there, even hidden between this plate, for example, and the steel pole pieces, it'll lose out eventually, and it could cause you havoc. So you want to get it all out. There's one particular area where gunk could hurt you, and that's this rotating wheel. It's two parts. It's actually the armature part, which is the part that moves, and it's this brass wheel that move independently of each other. They are not one part. Coming out of this thing, you'll think they are, because doggone things won't move because the sludge has gotten in there and dried up. But you put it in and soak it for a few hours in the xylene, you'll start to see that it'll dissolve, and those two move relative to each other. Just kind of a footnote, the reason those parts are independent and move separately is the oil that comes in later after everything is clean. Between that and the existence of what basically amounts to a flywheel, it smooths out the action of the rotor and allows it to transition from one pole to the next as the line cycle changes from plus to minus, and keeps that rotor moving. So it's pretty important function. And if you make them one part, that's not going to work quite as well. So, all right. So how do we clean this mess? Well, first word of warning, never immerse a fiber wheel in an ammoniated solution. It's just not a good idea. It'll swell up and it'll probably permanently damage. Then we're going to have to do a course on making fiber wheels, which I'm happy to do anyway, but you know. And avoid carburetor cleaner. Everybody seems on the boards likes to talk about carburetor cleaner as you know, God's gift to clock cleaning. Don't use it. This stuff's awful. It's great for carburetors. I can tell you that. I've used it for carburetors. But for clocks, there's too much stuff in clocks that's sensitive to the solvents that are used in that cleaner. So be careful there. I use Zenith 77, waterless, ammonialess. Great stuff. We did this. We talked about this when we did our clock cleaning class. I don't know, it's probably a year ago now. But we talked about Zenith 77, and you use it straight up. You don't dilute it, and it's fantastic stuff. You're going to see this come up over and over in this presentation because it is so compatible with the components that are used in clocks. Anything that's brass and steel, yeah, you could use the ammoniated stuff as long as you promise to do a xylene soak. And rinse afterwards to get all that gunk out of there. So then you want to do your inspection, look close. Look at both steel shafts that you'll find within here on the center picture. You see one steel shaft that supports the rotor, and that's the part that spins in step with the power line and gets you the close control of frequency from the frequency of the power line into the clock's timing, and keeps the clock on time. You don't want I've rarely seen these wear, but when they do, they wear terribly. And if they do, you're going to have to just, two things you could do. One is find a piece of a drill rod that's the equivalent size and replace that. You could pull that out with a pair of pliers and replace it. I actually have done it and it does work. Not much you can do to polish it because it's part of a fixed, you know, there's ways of doing it, but if it's worn that bad to where you have to really consider repairing it or replacing it, just replace it. It's not that difficult. Look at the fiber wheel, make sure there's no broken teeth, cracks, chips off the fiber wheels. They do periodically fail because the resin over time that's used to mix up, you know, like today they have this fiberglass board that's used in circuitry. You can actually you can still buy the phenolic materials for that matter. But over 100 years, the resin tends to get brittle. Things just kind of start to crumble. Most of these rotors don't have that problem, but that's not to say they can't, because in order to start these clocks, you usually have to apply some pretty heavy torque to the other end of other end of that wheel, and that stress could cause cracks. So kind of be aware of that. The output bearing, I'm going to tell you about half the time, maybe 70% of the time, you're going to have to rebush it. And that'll be the case unless, of course, the rotor has been idle for about 50 years. So, and if you don't fix it, you put oil in, it's going to come out that way. And also, it's going to cause gearing problems down the downstream, in the rest of the clock. So, if the bearing's okay, to do the power polish, with put a toothpick or some kind of an appropriate piece of pegwood into a lathe and turn it and get all that gunk out of that bearing. And that might be all you have to do, depending on how much wear you got. Let's say you do have to service the bearing. What do you do? Well, you show on the left here, we drill out the bearing. We have the dimensions of the drill you're going to have to use. You turn up your long bush. I don't know, the hole size you're going to drill in the center is 0.72. And then you drive it in and you trim it flush, easy as 1, 2, 3. That's what it looks like when it's redone. And you can use, I would suggest you very strongly consider getting a couple of Alvord Polk reamers. I have not had an ounce of luck using broaches to open these holes. The bushings are too long. You end up with a tapered hole. Very, very short order, they get loose because of that taper. So these Alvord Polks work fantastic. And I think this one was number 49. 4-flute chucking reamer. I think you can get it for like $10 on MSC. They're very affordable. And I got the part number there if you want to come back and look at it later. And basically, they're as easy as pie. You mount it up just like you did when you drilled the hole in the rotor, and pass that reamer right through, and you get a beautiful finish. Then, if you want to create a little bit of clearance, you can touch it with a broach, but by no means make the hole to size with the broach. It just doesn't seem to work. Let's talk a little bit about some interesting lubricants. And let me tell you something. This is something I struggled with for 20 years, figuring out what works best in these motors as far as lubricants are concerned. And I'm really liking these products. And you're going to need all three of these, believe it or not. And these very, very affordable. I actually learned about these oils from Shoreline Lathe, and the original founder of the company actually guided me in the direction of these lubricants, and I'm glad he did, because these things are fantastic. They last. They stay with the bearing you're using, and they just last. And the problem I had, I've tried, the classic greases that everybody says you're supposed to use. Whether it be lithium or graphite or whatever the heck, they're all very short-lived, not very high performance. And last thing you want to do is go through all the trouble of taking these things apart, lubing them with something that just goes south on you within 6 months or a year. And I have had it happen. So these seem to hold up over a long haul. So just amazing that they had found something as good as they used back in the day these things were being manufactured in the first place. And some of these rotors are still running with these doggone lubricants that they started out in. So it's phenomenal. But these lubricants seem to hold up. In some cases, we're going to need to mix these, and you'll notice that these have Teflon. The two on the left have a Teflon additive, and the one on the right does not. And the one on the right is considered a synthetic lightweight oil, works great, but it doesn't have the Teflon in it. So, and you can mix to get a viscosity that's off of what these things start out with, by combining these, and because they're all compatible with each other. On the lid, the first thing you'll get what we started out with on the bottom left here. This thing's a wreck, and you cannot put this thing back together looking like this, because you'll first of all, this particular rotor, this was pushed in so far that it was actually touching the wheel inside. It was causing a little bit of a problem, as you can imagine. So we had to straighten that out, and we had to clean up the button so that it would fit the hole. I actually had to open the hole up slightly after we unbent it and flattened it out, so that little rivet would go back in, the little button would go back in. And now's the time to do all that. Once you put this rotor back together, there ain't no way you're going to be broaching no holes on the outside. This is not going to be a good idea. You know, otherwise you'll end up with particles inside the rotor, your nice clean rotor. So clean it up good, oil-free, flatten the area around the button. Clean out that outside edge with Scotch-Brite, and after you do, keep your fingers off of it because you do not want finger oils on there prior to soldering. And make sure you clean up Scotch-Brite debris. You could do that by blowing it off or whatever method you want, putting it back in the naphtha rinse. Just make sure it's clean. And then just double check again that button, make sure it fits, because it's going to be too late once this rotor goes back together. So let's talk about how we do the reassembly. And I don't show a lot of detail here because there's practically nothing to these rotors. It'll be pretty obvious once you have one in your hand and it's apart. There'll be a couple bearings you want, after you've taken care of all the wear, you want to put a drop of oil on each one of the bearings. Just a drop now, don't try loading it up with oil, it's in the right time. And by the way, one thing I didn't mention about the super lubes is they're high temperature lubricants. 450 degrees Fahrenheit they're rated to, which makes them very compatible with the soldering temperatures we need here for the reassembly of this. That's another reason I love that lube. To hold it all together, sometimes once you pop these plates together, you don't need to do any more. They do not want to come apart. But if you feel uncomfortable about that, you can give the top rivets there a little peening with a hammer, supporting underneath with an anvil. And do install that output pinion now because it levers against this back plate. And if you start pounding it on, once the rotor is together, it's going to pop the plates apart. So let's get that pinion on there. I don't show it here, it's on the other side, but let's get it on there while you can support the rear arbor there where that drop of oil is. You want to be able to support that while you go ahead and drive that pinion back on. So then you take a piece of 18 gauge solder, leaded solder, of course. Don't use the new electronics, newfangled non-leaded stuff. It will not work in this case. So you want to use the standard that's called eutectic 60-40 solder, 70-30, something in there. Not that critical. And form basically a circle out of that solder about the size of that lid. So that sometimes helps if you wrap it around the 1.5 inch pipe that we had before, and then push that onto the lid and just kind of work your fingers to get it to lay like I show it here. It's not hard at all. It's soft and it's easily formed. So then you take some of this rosin flux, MG Chemicals. You can get it on Amazon. It's cheap as dirt. And you paint a band of that rosin flux, an 1/8 inch off the edge, nice and neat like that. It almost looks like something you'd see in how it's made, but you know, no kidding. It's not hard to paint the stuff. So now we're going to solder it, and to get ready to do that, we go grab our Schedule 42-inch brass tube, the 3-inch long one, and set that on a piece of steel or aluminum. If you could see there, I just dropped it on a piece of aluminum. Real important, folks, smear a little bit of engine oil on this edge where you're going to put the rotor. And just that little bit of an edge, and not a lot of oil, just a bitty bit, enough to be able to smear it on there. Drop the rotor in, pinion down, put the lid on, and orientation is super, super important here. You gotta have the oil button. Remember that oil button hole? That's gotta be away from the output pinion. So it's on the opposite side of that pinion. Then while you've got everything set up that way, paint some rosin flux along the lip, the part right here where you're going to lay this solder. So it's the bottom of the rotor right here. Everybody hopefully can see that. And then drop your piece of circle solder onto the lip, just as I show it here, okay? Everybody with me so far? Kind of? I don't hear anybody. I hope they're not sleeping. Then you want to take that piece of 1.5 inch Schedule 40 on top, and put it on top of the lid. You see that piece, we talked about it earlier. And then put a chunk of 3x3 by 3/4 inch steel block on top of it. And everybody's got one of these in their shop, I'm sure. And if you don't, go buy one from Amazon. They come in super, super handy. They sell them. Believe it or not, Amazon does sell those. What don't they sell? All right, so now we take our Burnsmatic torch. You can't do this with one of those itty bitty miniature little jeweler's torches. You need something with some serious beef, something that the plumbing guys use to melt solder on joints of plumbing. And this is almost a picture exactly of the one I have, and it works fantastic. Now what you're going to do is you're going to take that torch and you're going to blast it away at the tube. Now, do not heat the rotor, please. That will create a disaster. Don't heat the rotor, just the pipe. And maybe a ½ inch to an inch down from the top there. As you go around all the sides of this thing, what you're going to see is all of a sudden, that solder starts to melt because the heat will draw upwards towards it, and the little smear, if you will, of oil that you put on there will serve two purposes. First, it'll act to provide some thermal conductivity up to the lip of the rotor, and second, it'll keep the doggone solder from flowing down and sticking this thing to that pipe, and then you'll never be able to get it off. So it's pretty important. And I have been asked if aluminum would work. Yeah, actually, aluminum pipe would work if you can find Schedule 40 aluminum pipe. It would probably do even better because you wouldn't have the sticking issue to worry about. But anyway, continue to heat all around until you see it. All of a sudden you'll go, wow, that's the kind of joint I want. And when that happens, you just stop the heat and let it cool down on its own. It might take it a ½ hour to cool off. And when you're all done and it's cooled off and you can handle it, clean everything up with acetone and you'll have a beautiful joint there. Now, the one caveat is sometimes there's little pinprick holes. Well, those are easy to fix. What you do is you just brush on a tiny bit of that flux and heat it with one of your small jeweler's torches and just get that solder to flow again in that area, and it'll take care of that for you. You don't have to reheat the whole thing. The less you reheat this rotor, the better. You could also use a flux remover. There's electronic flux removers that you can use. Ethyl acetate is a very common one. It's really very effective stuff. You could use that to remove the flux as well. So now what you want to do is you want to put your little your button in there. But first, you want to dump about a ½ maybe 3/4 of medicine dropper of the super lube with the Syncolon into that hole. Get it to go in there. Then clean the heck out of it with acetone, because with that oil on there, nothing's going to stick to it. So you want to clean that up real good. Put the button in, dab a little flux, and then I'm not kidding you, just slightly heat it with the jeweler's torch, just enough to get a little bit of solder to flow on that. And don't heat too much because the solder will drip inside of the doggone rotor and you'll have a disaster on your hands. So just enough. Sometimes I do this with a soldering pencil, but that does not work very effectively, or one of those old soldering guns. It's just really slow. And a torch is faster. You just got to be real careful. You heat around it, don't heat directly, or you'll just burn up that flux and it won't do you any good. So, and it doesn't all of a sudden, you've got it, and it looks like this. And guess what? Sit back and admire. You've just restored a Hammond rotor. And they said it couldn't be done. Okay, any questions so far on anything that we've talked about? I don't hear anybody asking any questions, so I guess we don't have questions. Cool. I gotta get my screen share back here. Okay, every so often I check, make sure nobody's trying to get in. All right, if there's no questions, we'll jump right forward into the general time motor restoration, which also covers sessions, of course. So here's an interesting story how this started. I had a gentleman come to me by email and said, hey, I've got this motor that doesn't work. Can you tell me how to restore it? I'm like, over the phone? I really don't think that's going to work very well. So he said, okay. I said, send it out, give it a look for you. He said, well, I'm going to look at it myself first. So eventually, long story short, this motor got here and was a little bit pried apart, if you will. Let's just leave it at that. So it needed a little more TLC than they usually do, but it kind of turned out okay. So usually these General Time motors can be fixed without having to change any parts, with the exception of bearings and coils. And this motor was a little beat up. The rotor was literally unsalvageable, honestly. There was just nothing you could do. It was too bent out of shape to do anything with. I don't know, maybe if I had all the time in the world, I could have straightened it out. But I had a choice between all the time in the world and a couple of these things laying in the junk box. So you guess which way that went. And it's nice when you have some parts. And sometimes, you know, being fortunate, like I think Dick gave me a whole box of old junk motor one time. And some of those motors have come in handy for replacing parts. So thank you, Dick, for that. And in turn, if anybody needs a part from any of these things, let me know. I'll see if I can help you to return, kind of pay it forward a little bit for Dick's generosity and foresight. Now, you know, before starting the restoration here, yeah, I found the motor, old rotor in the box of junk. And it's a slightly different cosmetically, but it's the same exact rotor in every way. So I thought, well, you know, maybe you get some of these parts or whatever on eBay. You know what? I searched for this doggone motor. I couldn't find a single incident of it on eBay. It's kind of scary. So if you get an abused motor, you might have to do some hunting around for parts, or, you know, shoot me an email. Maybe I can help you find a part. Okay, so here's where I was talking about earlier, how many variations there are on this General Time motor. And you can see there's 3 there. The bottom one's a Sessions, but there's at least 2 other ones I know of. In fact, in the desk behind me, I've got 2 other designs of this exact same motor. Every dimension's the same except for the way they doggone mount these things. And that's enough to make them completely incompatible, unfortunately. So anyway, that's what kind of has led me over time. I mean, it's just so difficult to replace brackets, rivets, plates. That stuff's really hard to fix and change. So if you want to go and change the movement to make the new motor, a new motor fit, good luck. It's real hard to make that work too. Which thus is the genealogy of that's led to my compulsion to fix these things over time. So, and as I said earlier, a lot of the techniques we're about to talk about here work equally well on Sessions motors, which is really delightful. There's a lot of people out there that want to repair Sessions clocks, Sessions chime clocks, and master crafters. The better master crafters use that same exact motor. So where it all starts is where it all starts. In this case, it's get the rotor off. And the best way to get the rotor off is to first support the bottom of the rotor or the motor with, you know, all this piece of brass here I'm showing on the left, that's just a chunk of like 3/4 inch rod cut down, stuck in the lathe, cleaned off on both sides, and then center drilled out. That's all that is. It's just anybody can make that thing, and it'll take you 5 minutes. So you start with that, and then you have something solid to rest the motor on. You've got to support the core of this motor, or otherwise when you start pounding on the top, you're going to have bad things happen. And once you take a look at the underside of the motor, it'll be pretty obvious what I'm talking about. You want to clear all the rivets and all these other things that are under there. And that's the easiest way to do it. And I just so happen to have this big honking anvil, beautiful little thing. You know what? You could use that 3/4 inch 3x3 thing off of Amazon that costs $10 and it works just as well. So you just need something that'll relieve the bounce. So then you'll see here, I use this is a kit you can actually buy, these small punches. This is a kit that actually you can buy from, you know, Mile High if you want to. I think, in fact, that's where I bought this. And when they break, you just go out and buy more of them. And eventually, no matter how careful you are, you're going to break 1 or 2. But the point is, you want something that can hit the center of that shaft without affecting the bushing that holds this rotor together. And a couple of very light taps. You could use one of those tiny little brass hammers, jeweler's brass hammers, and that thing will just pop right out. Easy as pie. And once you do that, now you have access to the bearings. Well, let me tell you something. Let me tell you something about these bearings. Try as I may, over probably the course of a good part of a decade, I had no success in keeping these motors running until I finally figured out that I had to get those bearings the hell out of that motor first, clean them, and then re-lubricate them properly, and then reinstall them. So at this point, let's just do it. Let's get in there with a 3/16 inch chunk of brass stock, cut down to maybe 3 inches, and let's just use it as a punch and drive those bearings out. And what you'll end up doing is these, first of all, a little trade secret here, which isn't such a secret. This core is bored straight through one dimension. There's no steps in it. There's nothing fancy. It's just a single bore, which means that if you drive this top bearing hard enough, it will drive to the bottom and push out the bottom bearing right along with it. And getting it back together is not that difficult. So that's what we're going to do. And so we drive this out and we end up with what you see on the right side. And again, this is the only way to guarantee that this motor will keep running, is to get those bearings out, clean all the dead lubrication out of there, and take care of business. Now, we're going to talk a lot more about bearings towards the end of this presentation. So we'll get back to this, but that's the message. Get them out of there. So now we have to decide how far we're going to go with all this. I mean, if the motor leads are intact, you know, the first thing we better do is look around, because if it's a General Time motor and you see a lot of little black flakes and little things that don't seem to look like they came from anywhere in the movement, chances are what you're looking at is a burned up, deteriorated, what's left of a winding bobbin that was used to wind those turns on that coil. And I have seen, I'd say 80% of these motors come in with nothing left of the bobbin except a whole bunch of little particles. Now, if you don't have that going on, okay, then the bobbin's intact. Maybe you can stop with servicing the bearings and the shaft only and you're good to go. But if the leads are missing or the bobbin is deteriorated and you see all these little black flakes everywhere, that motor cage has to be fully disassembled, and we got to get in there and replace the coil. On sessions, the bobbins and leads are often found in good shape. At least that's my experience. On the General Time motors, like I said, about 80% of the time, they're complete rubbish. And we'll show you what I mean by that. So in order to be able to see what's going on inside this motor, what we need to do is we need to take that 1.5 inch Schedule 40 pipe and put it to work. So we're going to mount it in the lathe, and we're going to turn that inside. We're going to bore that inside until it just fits on those outside pull pieces. And I can just push it in there and it holds tight. You don't want to bend those pull pieces. You don't want it so loose that the motor can spin. Then you put it in the lathe. And if you have to, use a 4-jaw chuck and get this centered. This has got to be centered. You're going to need, what you're going to do is you're going to see if you can make up a sharp V cutting bit for the Sherline. You could take an old boring bit and grind it up so that it has the right angle on it. And you just want to be able to get in there and take out that rivet that's holding that thing together. And it doesn't take a lot of cutting. It takes the slightest amount of cutting. If you make that bit the right angle, and start with, the default is pretty darn sharp. A pretty strong V there. You can see where I'm pointing. Don't cut into the unriveted part of that core. It's going to be a little tough to get this thing to stay back together again when you're all done. And don't go too deep. You don't have to. And once you've got that little cut in there, you just take a brass punch. You leave the thing in the frame just like it was, and you give it a couple of taps in the center with a brass punch, and boom, out comes that core. Well, look at that coil. You know, honestly, there is no bobbin left. And guess what you got here? You got a huge safety hazard for your customer, because all this wire, even though it's insulated, is just laying out against that core, waiting to wear through, short out, and cause somebody an electric shock. So there's no way we can reuse this coil. There's no way to salvage it. There's nothing you can do to put a bobbin back around it again. And usually when you get them this way, the windings have already started to break apart from each other, and they're just a big rat's nest. You can't work with it. So we're going to throw that coil away. We're going to learn from it, but we're going to throw it away. But first, you know, you could see again the black flakes, and you'll see those in your movement as a real telltale sign that things are going south with that bobbin. So let's clean this thing up and get at that coil. So here again, Zenith 77 comes to the rescue. Aluminum does not like ammonia and vice versa. And so if you try to clean aluminum in the ammoniated clock cleaning solution, it's going to turn black and it's going to get ugly and it's going to bubble and all kinds of nasty things. So you don't want to do that. Use the 77. It's beautiful. It cleans it, brightens it up. It's great. And then a naphtha soak to make sure there's no water left in the thing. Rinse it up, and we're ready to go to work on winding a new coil. So I took my coil and I laid it on this piece of 1 3/8 inch Delrin or acetal. You could buy acetal for like 15 cents a foot or an inch or something at, you know, places like Online Metals and Plastics or Professional Plastics or Interstate Plastics or anywhere else. I mean, this stuff is not hard to find. You don't need to use Delrin. You can use acetal. Delrin and acetal, the only difference is that Delrin is the DuPont version of acetal, and it has some mechanical properties that are better than acetal, but you don't care in this case. As far as melting temperature, operating temperature, all that, they're identical. So the acetal that you can buy anywhere is fine. And in this case, it's a 1 3/8 inch bar stock, chopped down to a few inches, mounted in the lathe, center drilled out. Unfortunately, my lathe is a German lathe. Well, that part's not unfortunate. The unfortunate part is that it's only designed to go up to 400 thousandths, 0.4, which is 10 millimeter bit sizes. Now, if it had been an American lathe, it probably would have been good to a 1/2 inch, and I wouldn't have to bore it out. But unfortunately, I have to bore it out. You can see the boring bit on the left there. And I bore it out until the core fits, and look at that, beautiful, I'm ready to go. So then I focus on getting 40 thousandths inch wall thicknesses. Now you're probably wondering, well, how the heck do I know what the sizes should be? Well, the only other dimension that really matters is the length. And I'll leave, when I finally put this up, I'll leave the sketches that I used to make these, but you can easily measure them off the old bobbin or off the old coil, or for that matter, off the core. You could figure out what the length has to be. It's not that difficult, but I'll leave the sizes anyway. But just be careful, because sometimes you get an oddball that has a slightly different size. Usually they do fall into the pretty close range of what I have in my sketches, so I'll leave those sketches up. And you can see here where we're ready to part it off. We're ready to have ourselves a bobbin. And there it is. On the left, we have a nice little Delrin bobbin. Probably wondering how I cut that channel in there. Well, all I did was I took a standard cutting bit and, you know, a Shoreline, or in my case, I have a 3/8 inch cutting bit for the bigger lathe. Doesn't matter how big it is. And just cut an edge on it so that I could just plunge into this thing and get rid of that Delrin. Delrin cuts like butter. Acetal cuts like butter. It's the easiest thing to work with. You'll love it. It's fun. So anyway, my bobbin on the left now, it doesn't look like it fits. It almost looks like it's sticking out a little bit past the shoulder, and it does. But that's only because there's a leaf spring under here that pushes that bobbin up against the other side of the frame to keep it tight so it doesn't hum. When I depress this thing, I find that I have plenty of room. So you see, you got a little play here as far as this length is concerned. You almost can't miss, as long as you're reasonably careful. So to put it another way, if I can do it, any of you guys can do it. So then I make up a quick mandrel, again out of Delrin, center drill, and tap it so I can put a screw in here. It's not real critical what the size of the screw is. In this case, I use a 1032, a standard hex black screw, and a washer. In this case, it was just a scrap of brass that I cut into a circle and stuck on there. You probably could just use an off-the-shelf washer if you find like a fender washer would work great. Doesn't matter, it's not that critical. The idea though is that you have to support the size of the bobbin on both sides, because otherwise once you start loading wire on this thing, it's going to push outwards and lose its dimensions, and then you're going to have a hard time fitting it into the motor cage when you're all done. So both sides have to be supported. And it doesn't take long. I think it takes about 5 minutes to make this mandrel, and you've got it forever. And the next time you want to fix one of these motors up, you got it. You just pull it out and use it again. So here, now, I do have a winding machine now, but I got to tell you, that's after about 10 years of winding these things on a lathe by hand. So you do not have to have a winding machine to do a good job of this, but sure is convenient if you do. And this is a product I bought from a fellow in England, and it is a really nice machine for the money. So if you are planning on doing a lot of this sort of thing, and it kind of turns out I do a lot of this sort of thing, it's good to have the winder because it makes this hands off. Otherwise, you got to sit there with your fingers on the piece of number 40 wire and guide the wire back and forth on the bobbin, which is okay. It's just, you're not doing anything else for the next 40 minutes. So you got to be careful, and you don't want to pull too hard because you want to break the wire. So it's a little stressful at times. This thing makes it hands off, easy, stress-free, which I kind of felt like a good idea. So here you see on the left, the windings are about done. We got our 5,500 turns on there. And then I take this 3M56 tape that you can buy. I'll show you where to buy it. It's inexpensive, but it's meant exactly for this kind of application. And you wind about a half dozen turns of that tape on top of that wire. And then you terminate the wires. You see I made a little shape of a hook in that wire, and turn that wire around and put a little loop in the number 40 wire, wrap the 40 wire with a pair of tweezers around the stripped end of that wire. And you apply a little heat gently to it. And because of the type of wire we're using, the insulation burns right off right there. You don't have to worry about scraping it. Goodness help us if we had to scrape this wire. Oh, that's almost a guaranteed disaster. So here we don't. It's a 155 degrees C wire, so it burns right off in the 190 degrees C or 185 degrees C soldering tip, and it does so happily and readily. So then after I've got both wires soldered, I go ahead and wrap another half dozen turns of the 3M56 tape on it, and I have a coil, and then I can mount that coil right into the frame box. Some notes on winding the coil. We can talk about these now, or we can maybe just real briefly, but you can come back and refer to these. Number 40H, 155 degrees C wire is what you're looking for. Two advantages. The H means it's double insulated, so it's got better high voltage performance. Although at 120 volts, you'd be surprised how little breakdown you really need, because every winding is laid over another winding. It's only a few volts apart. So it's not like a big deal, but it does give you a little bit of a sense of security there that you've got a stronger insulation in case some abrasion happens while you're winding it. Get all the burrs off the bobbin. Use some 400 paper and clean them all off so that you don't get snagged in the middle of a winding. Now, this is a real important one that we haven't talked about. The start lead, the wire that's underneath in the bottom of the coil, needs to come out along the side of the bobbin and be covered with that 3M56 tape all the way up and out, so that the wire itself does not touch the wire that you're winding onto the bobbin directly, because you want to maintain good breakdown and you don't want to abrade that wire. So let's run that up the sidewall of the bobbin with some number 356 tape covering it, and leave a few inches extra wire there for when it's time to terminate. Then you overwrap 6 to 8 turns, as I said, before and after terminating the wires. Keep the solder joints smooth, no points or stalactites, because those will cut through the tape if you're not careful. Keep the terminations away from each other, maybe a ½ inch. Remember, for 120 volts AC, UL, for surge requirements, wants numbers like 4,000 volts. So the further away you keep those wires, within practice, within reason, the better. Delrin acetyl is an excellent breakdown material. It's fantastic for this application, but play it safe. Leave the walls of around a millimeter all the way around between any metal and the wire that you're winding on there. And when you're all done, you'll have a safe coil. Use Alpha 3053 appliance wire. Don't just go up to Home Depot, buy wire, because if you do, you're not going to know what the hell it is you got. 3053 you can buy from Alpha on Mauser. They can get the tape from Mauser. I have the part number here. 3053 is the part number for the wire. And sometimes I'll put a little bit of shrink tubing around the wire where the wire exits the frame of the motor so that it doesn't get abraded. I don't mind the shrink tubing get abraded, but oh, we really won't want that wire getting abraded. You know, cracks and pits in wire don't go well towards good insulation. So to reassemble it, not bad. What we're going to do is we're going to take everything and put it back together again. We're going to align. See here, we're on the right. We're going to align the pole pieces in between the pole pieces that are built on the outside of the frame. You want to be pretty close to halfway in between. If they're a little off, that isn't going to hurt you. Just don't have them overlapping those pole pieces. That wouldn't be good. And one day we've already done a little bit on this. We need to do a little theory on how these motors work. It's tremendously fascinating. It just amazes me how much they figured out 100 years ago on how to make these things work. So anyway, getting back to this, we got the core coming through and we've seated it. Usually if we've done a good job of cutting it, it'll hold itself together pretty well without having to do anything, just by driving it on and, you know, pushing it and wiggling it a little bit and getting it back in place. And then you'll just take a little round end punch and dimple like I show here at each one of these locations. Now I only do half of these. I could do 3 more, but you really don't need it. With those dimples, this thing is not coming out. And there's no force pulling it out in the first place. So you're kind of in good shape. And you got a situation where the next guy that works on this motor has a chance of being able to ping this thing back together again. So that's kind of the logic behind that. And it makes a nice, clean looking repair. So, all right. Any questions on anything up to this point? No questions? Okay. Let's talk bearings for a second. And I want to thank Dick for having given me the inspiration to figure out what I'm about to show you, because he asked me some questions one time and I was like, shit, I don't know. I'm going to have to look into that. And I did. I found some things out that I'm going to share with you now. So you get the bearings out, now you can work on them. By the way, I have had to make new bearings for these things. It is a piece of cake. Some 544 bronze and you can cut new bearings. Now, they're not going to be sintered bronze, but you can certainly make machine bronze bearings like are shown on the left. And they might last longer than any of us. That 544 is a really good alloy. It's machinable and it's very long lasting. So, but if you have sintered bronze bearings like are shown on the right, we need to pay special attention to those. And by the way, this is driven out the same way as we talked about driving these other bearings out earlier. You just take that punch and drive them right out. And you'll find those sintered bronze bearings common in sessions motors. Not so much in the general times, but you'll see them in the sessions. And not to say they're never say never. You'll never hear me say that you'll never find sintered bronze bearings in a GT motor, because I'm sure there's a few out there somewhere in the older motors. So some folks just say, well, just put a drop of oil on the drive shaft on this thing and call it good. Well, don't you think I tried that? Don't you think we're here talking about this now because that never worked? And here's why it never worked. It never worked because you've got all inside this thing. If you don't drive this bearing assembly out of here, you're going to not realize that you've got all this crusty, dried, varnish-like crud inside this thing trapped and baked to death over, who knows, 50, 60, 70 years of heat and time that turned this thing into what it is. You start adding oil, and what happens is these little pieces of crust start to work their way into the bearing, into the active area of the bearing where the shaft is, and they jam it, and the motor stalls. And you're like, dang it, didn't I just fix this clock? Now you think, okay, I'm gonna go put more oil on it. And then you go inside this thing and you go, wow, where did all this crud come from? I thought I cleaned this thing out. No, you didn't, not unless you took this bearing out and cleaned it until it looks like this one on the right. So yeah, there's something you gotta do. This is call this, secret, to my success number one with these motors is get the bearings out and clean them. Don't try to do this without taking those bearings out of the assembly. It won't be successful. So to clean them, if it's machine bronze, you can use ammoniated, it's fine. What you'll find though is a lot of this oil in these general time motors, this grease, seems like it's in good shape. And it's only the middle hole that's got the oil in it that's dried out, but that's not true. If you dig into this, what you'll find is this grease is way, way too thick for this motor. So that just happens over time in heat. So go ahead and clean it out. Rinse well with naphtha, power polish the holes, and blow. And when you're done power polishing, blow out all the residue because you don't want little scraps of wood in these bearings. And get everything cleaned out with naphtha or blow it out with an air compressor, whatever works, whatever you're comfortable with or whether you do in the shop. On sintered bronze, things are a little bit different. You want to clean that with 77. You don't want to use the ammoniated clock clean because guess what? Sintered bronze means these doggone things are porous as all heck. They're like sponges, and they will absorb a certain amount of the cleaner. Do I mind if I get a little Zenith 77 in there? No, because it's kind of an oil base anyway. So then I want to rinse it really well with naphtha and blow it dry so it's clean like you see. Then what you'll do, get on a pair of gloves, by the way, I should mention that here. And you're gonna wanna heat this whole thing up slightly. And not a lot. I mean, if you start heating it and the oil that comes out starts to turn brown, you're heating it too much, stop, because you're burning the oil and you don't wanna do that. But if you heat it slightly, it'll start oozing out as oil. Some of it'll be a little funny looking, but some of it might even be clean. And the reason it's clean is because the oil on the surface has dried out over time, but there's still good oil buried deep in those pores. You can't use it anymore, it's too far in, but want to get it out of there. So warming it up will tend to drive out the oil. Tamp it carefully, wearing gloves with a cloth or paper or something, paper napkin or something. Repeat that twice. And I say paper napkin because I know you be careful with that torch because you don't want to get it near the paper. But if you heat that bearing up to where it can singe the paper, you are way too hot. So if I were to put a number on it, I'd say about 300 degrees is about as high as you pretty much need to go. Do that twice, and by then you'll notice that there's not much oil coming out. So once you get to that point, get in there and power polish all the dirt out real thoroughly, blow it out just like before. Now reheat it again to about, like, again, 300 degrees and drop it into a container of oil. The oil you want to drop it into is our Teflon oil that we talked about earlier. And what will happen is the heat and the sudden cooling will pull that oil back into the pores of the sintered bronze where you want it. Now, we're not going to just count on that alone to lubricate. You'll notice in this assembly at the bottom right, there's a little hole there, a weep hole, which, by the way, you also want that clean. Sharpen a toothpick, get in there and get that clean. And we're going to put grease on this whole assembly before we drive it back into the motor. And then you got a little reservoir of grease there too. And that's what you need to do to get these lubricated up. Now, for general time in sessions motors like this with these frames, I've had the best luck with mixing 70% of the super lube grease with 30% of the Synclon multi-purpose oil. And the reason I emphasize this is because the grease as it comes out of the super lube, as is just plain too thick for these motors. But you mix it with a little bit of the oil and you get a beautiful consistency that works really well. And you're better off, honestly, going a little bit oily than a little bit greasy in this case. You're going to make a mistake. Mix it up until it starts to be easier to slump. You know what I mean by that is that you turn it and it starts to kind of fall over itself. That's a good consistency. This super lube grease coming out of the tube, it'll stick to a ceiling if you want it to. It's pretty heavy duty stuff, and it's great for gearboxes. But for these lightweight motors, you do want a grease like this, but you don't want it that heavy. So mixing these two up, even if you go 50-50, you can't go too far wrong. 70-30 seems to work though. I mix in a little jar and then I just pull it out with a toothpick and put it where it needs to go. And that should about do it. So, anyone have any other questions or any questions?
Hey, Ken, it's Terry. Back to your Hammond motors.
Yes.
I've got a porcelain clock, and it had a Hammond motor in it. I sent it away to a guy, and the state of Washington a few years ago and never got it back. Is it possible to find the Hammond motors used or otherwise and
I got about a dozen of them.
facilitate them?
I've got about a dozen of them in unrestored condition. If we, we could talk about that later on. I'm sure I'd
Okay,
help you out with that.
great.
So yeah, I mean, there's a guy that does Telecron rotors. His name is that's his name, Dave F. I'm trying to think of his last name, but I'll think of it. And he does actually talk about him on my website. He does what I would consider a reasonable job with Telecron rotors. If somebody wants a rotor-only restoration, I usually send them to him because I don't want to do rotor-only restorations. I want to do the whole clock. So what I'll do is work with him on things. And it turns out that for all that, he tells me if he has a Telecron Hammond rotor, and I work with him. As a result of that, I work with a lot of these rotors that I can share with someone if they needed a rotor. Now, if somebody comes to me and wants 12 of them, sorry, not happening. But one, yeah, that's okay. We can talk business on that. So.
Hey, Ken, Eric Funk, Kerrville, Texas, Chapter 15. I shot you a chat note asking what sort of time investment you typically see on one of these motor projects.
Yeah, generally, I mean, really between the two of them, they're about the same. I would say it could be 3-4 hours.
Okay, thanks. That's with your experience, starting cold as I would be, I would plan to invest more time than that. If I had a 3 or 4 hour target as sort of a goal, that would help me price that to customers and see if sort of test the shape of the demand curve. Thank you.
Yeah, I see. I'll tell you what, I see a lot of demand with these things. I mean, I wish I had, especially these days, it's not so easy. I wish I had an apprentice here to teach some of this stuff too, to help me out. But with COVID and everything, it's almost impossible. But even without it, it would be great to have some folks, helping out with these things, learning the trade a little bit. Because I'll tell you, I mean, this thing with these electric clocks, it's just getting worse. There's getting to be more and more of these things that require help because they're aging out. I mean, it's about that time, and most of these things are reaching the point where they're just not able to go anymore. And so all of a sudden, I mean, over Christmas this year, I got like 12 requests for Telecron clock rotor restorations, the whole clock actually. But a key part of that is the rotor. Yeah, I know we didn't talk about those here. I mean, someday we could. I did a whole series of articles on those in the bulletin if you're looking for some information on how that's done. But I can't believe how much interest there are. It boggles my mind how many people want their electric clocks restored. And I'll tell you, some of them that come in, you go, wow, no wonder they want this thing fixed. This is a beauty. The clock itself is just gorgeous. I mean, Jay and I worked on one for our customer in Austin that it was an absolutely gorgeous grandfather clock with an electric movement. And, you get that thing running again and it'll run for, you do it right, it'll run 10, 15 great years of, listening to that. It was I can't remember how was it, 8-tube Hershey style. I think Jay's on here, maybe he remembers better than I do, but it was a gorgeous clock. And you can see why people want to have these things running again.
Hey, Ken, Tom Murray. How did you know, I think it was 5,100 turns or something of wire that you put. How did you know how many turns of wire to put?
Well, that's a really good question. So what happens, it's actually 55 turns, but pretty close. And funny thing is about that the sessions motors are closer to 4,800. And the reason they're different is because the bobbins are a different size and shape. And so there's a couple of things I shoot for. And, the most important starting point on how to figure these things out is just make a ton of measurements, physical measurements with the calipers. And believe it or not, you can actually do a really simple geometric calculation, knowing the thickness of the wire and the, amount of space, the amount of area there is on that bobbin, and get really close right there to the number of turns, and you'll be a little off. But then, once you know that, you can also calculate the length of the wire. Once you know that, you can figure out what from the tables of ohms per foot for that particular gauge wire, you can calculate what the DC resistance of that thing is, what that winding is, and you can compare that to the measurement that you can take off of a good motor and see how close you are. And truth be told, first time I wound any of these things, I got it wrong. And taking wire off is a really difficult thing to do on these things, because to make an impact, you have to take 200, 300, 400 turns off. So next motor you do, you learn from that mistake and you get closer, and eventually you come up with a formula, use it all the time, and it just works. So that's why I said I'm going to post up what the parameters are for anybody that wants to peruse it. Now, when I rewind Telecron or Hammond coils, it turns out that quite often they literally stamp on the side of the coil a number that represents the number of turns on the coil in 100s. So for example, you might see a coil marked 65. That's 6,500 turns, or 70, which is 7,000 turns, or 56 or 48. Those are the most common that you run across, and those represent the number of turns. So that makes life really easy. Now, the only trick with those is, the turns matter more than anything else, because the turns is what gives you the magnetic properties and ultimately the inductance, which provides the impedance to the AC signal.
Yeah.
But it's a vector.
Oh, all right.
But it's a vector, and so the DC resistance counts to some extent too, although to a way lesser degree than the number of. And so all that does is it acts as a yardstick to help you figure out how many turns need to go on it. It's a long story, but you get the gist of it.
Yeah, no, thanks. Good explanation.
Ken, you said, it's Terry again, you said the Hammond motors needed a little start. Well, the one that I bought years ago, it's porcelain shaped like a windmill that hangs on the wall, and the clock is around the periphery of the windmill. And then it has a little operational windmill with metal arms on the clock itself. And you would start that windmill with your finger to get the motor to start.
Yeah.
And one time I was playing around with it, and I wound the little blade of the windmill blades counterclockwise, and it caused the clock to run backwards. So I thought that was sort of fun.
Yeah, it is kind of fun. They don't care which way you turn them. They'll run either way.
Yeah.
Those self-starting synchronous motors are happy either direction. So you can watch time go in reverse if you want.
Yeah.
Before you can get a motor to self-start and run in a continuous direction, you have to do something that's called shading the poles. And the general idea behind shading the poles is you put a conductor in there that actually, in essence, blocks the magnetic field, but not entirely. Only because the magnetic field is present, only because the line voltage is changing constantly. What that shading pole does is it kind of provides a delay to the magnetic field, so that the other side, that's basically the side of that where the shade is, that magnetic field comes up a little bit later, which means that now you've created a rotating magnetic field by having a pole right next to a pole that's not shaded, actually, provide a slight delay, which then makes the magnetic field kind of rotate around the set of poles. And that's how you actually achieve getting a motor that starts by itself and goes in one direction.
But
So anybody,
is there a magnet in these motors? It wasn't clear to me that there was.
well, no, there's just highly magnetic materials that have a high amount of hysteresis. In other words, they magnetize themselves because you applied the field initially, and then they stay that way while it's running.
Okay.
Not actually a magnet, it's a very high reluctance magnetic material. And you'll notice on the if you ever take apart one of these, and hopefully you'll challenge yourself to do it, take apart one of these General Time motors, flip that rotor over sometime and look at that thing, and you'll see that there's a little band of magnetic material inside that aluminum frame rotor. And that's where all the action is. That's the magnetic material that has that reluctance property with hysteresis that self-magnetizes when you first apply the power. I mean, one day it might be interesting to do a really brief little thing on how these motors work, because they are fascinating. And how they figured all this out, you know, without any instruction manual. You know, what is it, 80 years ago? Whatever it is. It's pretty crazy. Any other questions this evening? None. Well, Terry, contact me and we can, you know, badger around what to do with this rotor. Yeah, get it restored for you.
Will do.
I got lots of restored.
I'd love to have it working again.
Yeah.
There was a guy in our chapter, not our chapter, in the National. He was actually a fellow, and he did a program years ago. He's deceased now. I forget his name. He was out of Chicago, and he had a collection of porcelain electric clocks, and he did a program that we got a video of and had as a program one time a few years ago. And the title was Porcelain Electric Clocks, Doubly Collectible, because porcelain collectors like them for that part, and the clock collectors like them for as a timekeeping part. So
Yeah.
you don't see many of them around anymore.
Yeah, they're gorgeous. So who was it in chapter 15 that loved working on these electrics? Was that you, Jay Pine? Trying to remember. But I think there was a fellow in chapter 15 that collected a lot of electrics of all sorts and sizes. Did some presentations for the group. I thought I saw him in here, but maybe I'm wrong.
I can't get my mic to work, but it's me.
Oh, okay. So it is you, Jay. Oh, okay, cool. Great. Glad you're here.
Yeah, me too. Very informative.
Yeah, thanks. Cool. Okay, well, I guess that would probably be about it if no one else has any other questions. As I kind of indicated earlier, we'll see if we can get this posted up at the very least to my website, Ken's Clock Clinic. And if, with a little luck, maybe we can get a little help from Andy and get it up on Chapter 21's website too. And then you can use it as a reference if you need to look back on it, or you decide to get brave and do some things with these motors.
Hey, Ken?
Yes.
Yeah, this is John Neal again.
Hey, John.
I used to like these little Master Crafters and United clocks.
Yeah.
My experience with all of them that I ran across was not the motor, but the gearing. Do you do anything with the gearing?
Oh, you can. Unfortunately, I should say. Well, I hate to say unfortunately because it feels that way sometimes. But yeah, those clocks are a pain in the butt because you're right. The gears wear out, and they're usually nylon gears, and they either fall apart from age or just wear out or whatever. And so, yeah, I end up having to make gears for those things, and I usually have a reasonable amount of success. Personally, I don't collect them because they're so doggone noisy. Even when everything is absolutely right with them, they still make noise. It's just kind of the nature of the beast. Some people like that. But yeah, I have way too much experience with those things.
Do you make the gears out of fiber or wax or nylon or what?
Settle, the same thing. Delrin, just like with the rotors. I love Delrin because it is super machinable. If you ever want a plastic that you can machine that leaves behind very little swarf, now not none, but little, and super durable, self-lubricating, the Settle is it's the best stuff for that. I have yet to find a better plastic, and by the way, I've tried quite a few different formulations, and you just walk away, feeling really good. Now, like say for example, if the fiber wheel on this Hammond rotor kind of went south or was broken, honestly, there was a time when I actually make those out of Delrin, again, or Settle, but I came to learn that sometimes that's not a good idea because the soldering temperatures are kind of not totally compatible with Delrin's melting point. So I've gone away from, if you're careful, like what we showed in this presentation, you can keep the temperature inside the rotor from getting to the point where it can cause a problem for the gear. But I've gone back to just getting, sheet phenolic and just using that to make the gears. It cuts beautifully, and you can make it out of flat stock and make 10 at a time, and on it goes. I mean, I've kind of gone back to, and that's the same material that was used originally. And if you cut fresh, the resin is fresh, the stuff is not at all brittle, so you can make beautiful gears out of those things. So I guess the point is I'm sort of starting to drift towards using the same material that was in the clocks originally, except if you get some weird pinion or something, and then, you can't use flat stock, and then it gets a little bit challenging, and the Delrin works a lot better.
I forgot what they call them, but some of the clocks have a screw gear or, a gear that.
Well, that's a really interesting point you just brought up. The worm gears, gulp, on those Sessions clocks are a huge source of headaches. And the reason is because they look good. Even when they're worn to bits, they look good. So you go ahead and you say, so this thing still looks good. You put it in the clock, you start it running, it won't run. It stalls or stops or sticks. But then when you look under a microscope, you can see the trenches in the sidewalls of those quote unquote teeth. Well, technically, if you look at, you argue that, a worm gear has one tooth. It counts for one tooth, but it counts for one tooth in a continuous fashion. And those things just wear all the hell out. So you got two choices. Number one, learn how to cut them, which you can do on the Shoreline. And, Charles can show you how to do that. He's really good at cutting, basically screws on the Shoreline. Or you can go find a motor that has a good one and, steal it off that motor. So, but, when you're working with Sessions motors, you got to be constantly aware to check that really carefully, because those things, they just gouge out on the edges. And once they do, the motor will stall and you can't get it to run continuous. And there's nothing you can do. I've tried flipping them, going the other, knocking them out and flipping them. That sometimes works. You know what I mean by that is you turn them around, you knock them out of the shaft and then refit them on backwards from where they were. But they were not cut symmetrical. So you have to be really careful about the way you reinstall them. But yeah, it's a good point. Those things are a nightmare if you're not careful.
I agree. Thanks, Ken.
Sure. Okay. Well, anybody has any other questions, that they struggle with anything in this thing, you go ahead and feel free to shoot me an email, and we'll chat about it back and forth to help you out if you decide to get brave and tackle one of these things. All right. Okay, I guess that concludes tonight's presentation, and I appreciate, again, thank you all very much for participating. It makes these things fun and fulfilling when you have folks that are interested and want to listen to this sort of stuff, even though it's not a topic that probably is very common. The problems are a lot more common perhaps than some think. Okay,
Thanks, Ken. Great presentation.
Yeah, thanks, Cam.
thank you guys very much. Appreciate your attendance and your interest.
Yeah, thank you, Ken.
Thank you, Ken.
Thanks.
Okay, thank you, folks. And I guess unless anyone has anything else, we'll go ahead and we'll sign off now. All right.
Good night.
Take care, everyone. Until next time.
Avs winning.
What was that again?
The Avalanche are ahead 5-2.
Oh, good, because if they don't, they're going to get eliminated.
Almost the end of the second.
Yeah, fantastic. Okay, well, all you Avalanche fans,
Yeah.
keep it going. Okay, take care, everyone.
Good night.
Good night. Bye.
Presentation.